In this video, I'm going to show you exactly how you can use Excel to perform regression analysis. The way that I'm going to show you to do this will exactly follow how I am asking you to do it for the regression special project, the regression special assignment. So what I've done is I've gathered information on this spreadsheet that you can see in front of you from Yahoo Finance. I've given you those instructions on how to do that. You go into Yahoo Finance, put in the ticker symbol for the stock that you're interested in, or for the S&P 500, or for the 10-year Treasury. You go to the historical prices on the left-hand side of the screen. There's a link for that. Go to historical prices. Then you're going to select your date range, scroll to the bottom, and you will see the download link to download all of the data for your chosen time period. You download that information, it opens a comma delimited file, a .csv file. You'll pull that up, you'll capture all of the adjusted closing prices, because the adjusted closing prices are the actual stock price adjusted for dividends and for stock splits. That way you don't have to do that. Yahoo has already made that adjustment for you. That's why I'm having you use Yahoo Finance as the vendor for that information. And then you're going to copy that information into a worksheet, a workbook, just like this. And what I've done is I have this worksheet labeled as primary data. You can call it whatever you like. I have copied over the dates that came down from Yahoo. I just simply copy and pasted that. I've chosen to use Procter & Gamble, and so I copied their adjusted closing price. That's what you see in column B in this video. Then I calculated the holding period return for Procter & Gamble, which I'll highlight this cell so that you can see that the holding period return is simply the ending price minus the beginning price divided by the beginning price. That's the holding period return. We don't need to make any adjustments for dividends or stock splits or any of those types of things, because that's already been done in the adjusted closing price. I'm going to skip column D in yellow here, and I'll come back to that. I've gathered the data from the S&P 500 and calculated the holding period return for the S&P 500 using the exact same process. Gathered the data on the 10-year Treasury, the TNX, and I have calculated the holding period return in the exact same way. So columns B, E, and H are the adjusted closing prices downloaded directly from Yahoo Finance. You'll notice that there's a column K out here with the month listed in there. That's just simply for my own information. I did that. I did not instruct you to do that in the instructions for the regression analysis special project. I just simply put that there for my own use. You're welcome to include that if you want or not. And here's where I use it. I can see clearly I have 60 months worth of data. If I wanted to know how things went in month 40, I could go and take a look at month 40 real easily rather than having to count. I could just simply say, oh, I'm looking at row 41. So we have 60 months worth of data. This is our raw data, these three columns. And you'll notice that our holding period returns stop short by 1. So we have a blank bit of data down here, nothing there in either of these scenarios. The reason is because we can't calculate a holding period return unless we have the previous period's price. So we would need to have the next period's, the next oldest period's price, the December of 2009. We would need that price in order to calculate the holding period return for January. So we have excluded that. Moving back up to the top, I'll talk to you for a moment about the excess returns. The excess returns column is simply the holding period return on Procter & Gamble or the stock market in this column minus the holding period return on our Treasury. We're trying to get some idea how did Procter & Gamble perform relative to the Treasury, because that's what we would consider our standard opportunity cost in investing. I could either invest in a treasury. In this case, we're using the 10-year treasury because that's what's often used in practice. And I'd like to know if I was invested in the 10-year treasury, in this month I would have lost 6.41%. But over here, I would have gained 3.62. So my excess return is here. So that's what we are doing. That's the information we are gathering. Now we need to go and create our regression. And what we do is we go up here to the data, and then we go over here to data analysis, and you'll see this window pull up. I'm going to scroll down until I find regression and select OK. Now, it asks for the Y input range, the X input range. What are we going to do? What we do here is I make sure that my cursor is in the Y input range, and the Y input, that is our dependent variable. So our dependent variable, what we're trying to figure out, what we're trying to predict, is Procter & Gamble. So I'm going to gather all of those excess returns. Column D, starting in row 1, ending in row 60. Now I'm going to put my cursor down here for the Y input range. I need to scroll back to the top, and I need to gather my excess returns for the S&P 500. Again, starting in row 1. Since I started in row 1, which includes simply the data labels, you can see that up here, the data labels are in row 1, I'm going to check off the labels box. If I started with just the data in row 2, I would not check off the labels box. The labels box is telling the regression system, ignore the first line, that's just a label, that's just a title. Skip down to row 2 to start actually crunching the data. Then I'm going to go and I'm going to check off output range. I'm going to put my cursor in the output range box, and this is where I'd like it to appear. I've created a worksheet here where I hid all the grid lines just to simply make it look prettier. I'll show you how to do that in just a moment. And I'm not checking off any of these other boxes. And I'm going to say OK. And then it gives me my information. Now, you will not need to worry about this, the lower 95%, upper 95%. I'm just going to delete that information. Actually, if I go to delete here and shift the cells, then it will take all those lines out as well. And also the ANOVA output you do not need to worry about in this class. So I'm just going to delete that information as well. What we have left is information that you will be dealing with. And I'm just simply broadening each of those cells so that I can capture all the information that I'm looking for. Now, this is the regression information. And the regression information requires some interpretation. One thing you'd have to take a look at is the R-squared and the adjusted R-squared, which tells us how much of the model is predicted, or how much of Procter & Gamble is predicted using this model, which is against the S&P, the excess return on the S&P. And what we have here is an essentially 82.72% on the adjusted R-squared, which is actually fairly good. Now we see our standard error. You'll want to take note of that. You'll also want to take note of the coefficients right here. The intercept coefficient, which is your alpha term, and the coefficient on the excess return of the S&P 500, which is your beta term. Now, in this example, it's showing that it has a beta of 1.07 over that 5-year time period. If you check Yahoo Finance, it's not going to tell you 1.07 is the beta. That's because Yahoo Finance doesn't report a 5-year beta. They are reporting a much shorter time period. It might be a 3-year beta or a 1-year beta. Different services present different betas because they calculate it over different time periods. Some of them use the excess returns, as I've shown you here. Some of them don't factor the treasury, and they just record the S&P 500 versus Procter & Gamble, the raw prices, without factoring the opportunity cost of the treasury yields. I have included the treasury yield because I think that that is the cleanest way and the truest way for you to learn how to do this. So in this case, they'd be saying we have a beta of 1.07 and a slightly negative alpha coefficient. So if the stock market, if the excess return on the stock market were 0, meaning the stock market and the treasuries performed exactly the same, then we would expect Procter & Gamble to be losing just a little bit of money. That's what this model would tell us. That's when we have to come over here and we have to take a look at the t-stat and the p-value to think about how realistic is that. And what we can see is that our t-stat, remember I gave you the absolute value of 2 is the threshold to know if that number is significant or not. And in this case, the intercept term is not significant. The beta term is significant. When I look over at the p-value, I want it to be as close to 0 as possible. 0, not 0.56, 3875439. The p-value on the intercept term tells me that it is also not significant. So that alpha coefficient is not a true reading for Procter & Gamble. It is what the regression results produce for us. It's what the math produces for us, but it is not statistically significant. We might also say in finance that it is not robust. It is not statistically significant. It is not robust. The t-stat on the beta coefficient, however, is way above 2. So that is a statistically significant t-statistic. And the p-value, this e to the negative 23, suggests that we have 0.000000000, 23 zeros before we would get to this number here. So it is an extremely small p-value. It is extremely close to 0. So we would say that the beta coefficient is statistically significant. Our intercept coefficient is not statistically significant. So for your assignment, I want you to pick a stock of your choice, go through the steps that I've shown you in this video, come to the regression statistics, and then talk about what you found from your regression output. I do not want you to do Procter & Gamble because that is what I have already done, and I don't want you to just tell me something that I already know about Procter & Gamble. I want you to pick your own stock, come up with your own regression statistics, and then tell me what it means. That is the project, and I wish you luck on that project.